Hey everyone, welcome to my channel. I have started a personal DSA challenge where I am solving 5 problems per pattern, covering 180 problems in total. I'll be posting one video per day explaining my thought process from brute force to optimized approach. If you're new here, you can check out the previous videos to follow along. In today's video, we will work on minimum path sum. So the problem states that we are given a grid filled with non-negative numbers and we need to find the path from top left to the bottom right, which minimizes the sum of all the numbers along its path. If you choose 1, 3, 1, 1 and 1, the sum would be 7. But if you choose any other path, the sum would be greater than 7. Our task is to find the minimum sum possible before you reach the bottom right. So for the brute force approach, for the brute force approach, let's take some global variables int m and n and a 2D grid and the best answer so far initialized with the maximum value because we need the minimum value. So now we will check if this grid itself is null, or if the length of the grid is 0, then we will return 0. Otherwise, let's initialize this current grid with the global variable grid current m with the length of the grid and current n with the length of the columns, and let's call a DFS method. DFS is nothing but depth first search, and we will return the best answer. Let's implement this DFS. The return type would be void DFS, and we passed int I, int j and the sum. First, let's update the sum variable with the current value of grid I of j. Then we will check if the sum is already greater than or equals to the best answer, because we need the minimum. So we will return, because we need the minimum. If the current sum is already greater, then we don't need that. So we will prune it here. Now we will check if I is equals to m minus 1 and j is equals to n minus 1, which is at the bottom right. Then we will update the best answer with the minimum of best and the current sum, and then we will return because we have already reached the bottom right. Otherwise, we have two options: either we can move right or we can move down. To move down, we could say I increases if we move down. So if I plus 1 is less than m, then we will call DFS of I plus 1, the current j and the sum. This is to move down. If you move right, we need to increment j plus 1. So we will check if that is valid. If it is less than n, then we will call DFS of I j plus 1 and sum. This is to move right. That's it. Let's run the code. So yeah, this explores all the valid paths and keeps the minimum value. But the time complexity would be O of 2 power m plus n, because we have two options: either we can move down or we can move right at every step. So the time complexity would be exponential, and space complexity would be O of m plus n because we are using an extra grid. So since the time complexity is more, this is only for smaller grids, but this will lead to TLE for larger grids. Now we need to find a solution to optimize this. Okay, to optimize this, we again need MN grid and the best answer. Okay, let's take a tabulation. Let's comment this out, and for tabulation we don't need that. Instead we will first check the same condition. If grid is null or grid length is 0, then we will return 0. Grid length is 0, or the column length also, we need to check the column length also of length is 0 or not. If it is, then we will return 0. Otherwise, let's initialize m and n variables with grid dot length, and n would be grid of 0 dot length. Now let's initialize the first row. For that, for int, it starts from 1, j less than n, j plus plus. First row means grid of 0 of j plus equals to grid of 0 of j minus 1. Then we will initialize first column. For that, I less than m, I plus plus. For column, it would be I, the column is constant, first column grid of 0 plus equals to I minus 1 and 0. Now we will fill the rest. It starts from 1, j I less than m, I plus plus, j equals to 1, j less than m, j plus plus. Now we will update that current cell in the grid I of j with the minimum of grid of I minus 1 of j and grid of I of j minus 1. That is it. Then we will return the last cell m minus 1 of n minus 1. Let's run the code. It is accepted. I'll submit it. Okay, it is accepted. So we can alternatively use a 1D rolling array of length n to achieve O of n extra space while keeping O of m into n as time complexity. So yeah, that is it for today's problem, and I will see you in the next one.